In 1712, the Royal Society formed a committee to examine a bitter dispute between John Keill and Gottfried Leibniz over who deserved credit for inventing calculus, but the Society's president was Isaac Newton, and his own claim to priority stood at the center of the case being judged. The committee's report favored Newton. Surviving manuscripts later revealed just how deeply he had shaped it. The two men at the center of it were Isaac Newton and Gottfried Leibniz, working independently, hundreds of miles apart. Both had developed calculus on their own, the mathematics of change, of motion described precisely instead of just approximated. For decades before the dispute became public, almost nobody seriously argued that either one had stolen it from the other. Newton got there first, chronologically, around 1665 and 1666, working privately while Cambridge was closed for plague. He developed what he called the method of fluxions, writing the full treatise in 1671. Some of his mathematical results did circulate or reach print earlier, but the method of fluxions itself wasn't published in English until 1736. 65 years later, and 9 years after his own death, Leibniz worked it out independently, using different notation and a different conceptual approach through the 1670s. And crucially, Leibniz actually published, in October 1684, his paper appeared in the journal Acta Eruditorum, the first published account of differential calculus, years before Newton's own results reached print in comparable form. For years, that was simply how it stood to mathematicians, two different roads to the same mathematics. So what turned that quiet coincidence into a public trial decades later? In 1703, Newton was elected president of the Royal Society, a position he held until his death in 1727. By then he was the most famous scientist in England, author of the Principia, a man whose word carried enormous institutional weight, the kind that makes an accusation land very differently depending on who's making it. The accusation didn't start with Newton directly. Nicolas Fatio de Duillier, a Newton partisan, publicly raised the suspicion in 1699 that Leibniz may have borrowed from Newton's work. John Keill later revived and escalated that insinuation into an explicit plagiarism accusation. First in 1708, then in 1711, he argued in a letter to the Royal Society's own secretary that Leibniz had simply dressed Newton's method up in different notation. That accusation didn't stay private for long. In 1711, Keill's charge was published outright in the Royal Society's own journal. Leibniz demanded a formal retraction. When Keill refused, Leibniz did what any accused member of a scientific society might reasonably do. He asked the society itself to investigate and clear his name. The society agreed to investigate and formed a committee in 1712. But there was an obvious problem: who would actually be judging it? The institution conducting the inquiry was being led by Newton, whose own claim to priority stood at the center of the dispute. The committee operated inside the Newton-led Royal Society, its members appointed in stages, and the society had already published Keill's allegation and taken up the English side. Its final report declared Newton the first inventor. The report carried the authority of the Royal Society, but Newton's own role in shaping it was not disclosed to its readers. It appeared to the public as an institutional judgment. The Society published it together with the underlying correspondence as a single volume, the Commercium Apostolicum. The committee issued the report, but Newton supplied, selected, and organized much of the evidence used to support his own priority. He was effectively responsible for the case published under the Royal Society's authority. In 1715, he anonymously wrote a separate account defending the Commercium, reviewing the controversy in the philosophical transactions as though from outside. In 1713, Leibniz's side circulated an anonymous response known as the Charta Volans. Drawing on a private letter by Johann Bernoulli, it turned the plagiarism accusation back against Newton and his supporters. Newton considered it important enough to prepare a response. By this point, the argument had stopped being about mathematics at all. It had become two aging men, and their respective national scientific establishments, refusing to back down. The controversy dominated the final 25 years of Newton's life and consumed a large part of Leibniz's own later career, right up to his death in 1716. Newton kept defending the English case for another 11 years after that. The controversy hardened the national division. British mathematicians continued working largely in Newton's fluxional tradition for roughly a generation, while Leibniz's notation, the dx, and the integral sign, spread across continental Europe. The divide helped isolate British mathematics from continental developments in a dispute between two men who were, by any reasonable modern reading, both right. So, who actually invented calculus? Today's answer is almost anticlimactic after everything that came before it. Both of them did. Modern scholarship generally regards Newton and Leibniz as independent developers who reached genuinely equivalent mathematics through genuinely different conceptual paths, roughly a decade apart. Modern calculus still relies heavily on Leibniz's dx, and integral notation. Newton's dot notation survives too, especially for change over time. Newton died in 1727, still publicly associated with the official English verdict. But surviving manuscripts later revealed how deeply he had shaped the evidence, the report, and the public defense of his own case. The investigation meant to settle who invented calculus became a warning about something else. An institution cannot deliver an impartial verdict when one of the rivals helps shape the evidence and the public case behind it.